Hey, hello everyone. Today we have with us Herumb Shandilya, who is a grad student at Stanford who worked on machine learning system and LLM workflow optimization. He was also part of the marine project at Stanford CRFM, where he worked on the intelligence per watts project at Hazy Research. The reason we have him today on the show is because he happens to be the maintainer of DSPy for quite a while now and also responsible for his documentation website. Of late, Hiram has been working on DSRs, which is a Rust variant of DSPy, focused on optimization beyond prompts and signature. Welcome to the show, Hiram. It's so great to talk to you today.
Yeah, thank you so much for inviting me over. And yeah, thank you so much for giving me your time for this. It's really nice being here.
Awesome. You're the first DSPy core committer maintainer that we are talking to. So I've got so many questions to ask, but I'll start with the sort of the most obvious one. You've been associated with the project for quite a while now, and you've seen the evolution of DSPy. So what have been some of your like key learnings or highlights from this journey? And did you believe the project would get the traction that it kind of got?
Yeah, honestly, like the first time I used DSPy was when it was not even released. So one day
Okay.
Omar just pinged me. Hey, yeah, like Omar one day just pinged me. I was working with Omar for like about 2 or 3 months back then. And Omar one day was like, "Oh, hey Hiram, do you want to try DSPy before we even release it?" And I was like,
Right.
"Yeah, sure." And I was working at this company called 6A at the time. I was building LLM pipelines, and one of my biggest point of frustration was building these prompts handwritten by myself, and I had to configure LLMs every time. And at that time prompt engineering was a big thing, and so there were so many papers around this. So it was a black magic thing at that point of time. And so when I used DSPy, one thing that clicked me was I no longer have to worry about the prompt itself. Rather, I have to worry about the workflow or the pipeline that I'm building right now. And DSPy provided such an intuitive interface to it that it just clicked on the spot. And at that time, I really knew that this paradigm would probably be there for a long while now. And
Okay.
what really just made this more clear and more confident about this stance was there was this company called, I think it was Banana, who released a framework called Fructose, which was very similar to DSPy, but at a very functional paradigm of sorts. So I knew like this thing would probably get a traction. I just didn't know it would be this big. But yeah, I knew there would be a lot of traction around this, like every other thing Omar does. So yeah, I knew there would be tractions. The key learnings. So the reason I started working on docs a lot was because I knew DSPy was a really good library. But what I kept seeing from time to time was people didn't know how to get into DSPy or how to get started with DSPy. So I started building docs where I started explaining stuff on how things happened behind DSPy, how signature worked in the backend, how maybe module is implemented in the backend, how optimizers work internally, algorithm wise, and internally both. And I started realizing like people really need better docs for really good frameworks.
Mm-hmm.
And the more I started building docs, the more I started doing it, I started realizing that this is just one part of it. You need good tutorials, you need good documentations, you need good infrastructure that promotes both learning and the use case of the application framework itself. So that's one thing. And second thing was this was really enlightening in many sense was I started understanding what sort of abstraction just clicks with people
Mm-hmm.
for this. And
Mm-hmm.
it's hard to say what it is, but it's kind of those abstractions that offload the boilerplate that you don't want to work with
Correct.
and yet give you the control on specific things that you want to like. So
Absolutely.
with DSPy, that's the whole thing. You
Right.
offload the whole prompt optimization to DSPy and you give it the control of just defining the forward pass or tool executions and stuff with DSPy. So yeah, those that's roughly the thing that I really try understood about how to write a good framework, how to write good documentations, stuff like that.
I'm pretty sure it was a great learning experience with so many users kind of using it and the feedback also coming in. One of the biggest problems with a lot of startups is that you just keep on working to no end and you rarely get feedback, you rarely see traction. So one of the great things I think you lived that journey from 0 to 1 and now seeing the 1 to 10. from a library standpoint of view. So now this sort of brings me to the next question. In some ways, it looks like having a core maintainer sort of starting a project in a different language. That's kind of a little odd. So, what made you start a port in Rust, and what do you
Mhm.
think it brings to the table that you cannot accomplish in DSPy Python?
Yeah, that's a good question. So to be very honest, like at that point of time, I just wanted to do something in Rust. Like
Ah,
I,
okay.
I worked on Rust for a good while before, but mostly on data pipelines and stuff. But
Hmm.
I just wanted to build something really concrete and just build something good out of Rust. So I pitched a lot of ideas to folks, and none of them really clicked with anyone. And I have been pitching Rust to Omar for quite a while now. And so one day I saw Omar made this tweet about these are the DSPy flavors in different languages. And I was
Right.
like, shoot, Rust is not over here. And so I started started pitching the idea again to Omar. But this time I was like, hey, Omar, I created this
Right. Understood.
library and I'll just be working on this for a while. At
Got
that
it.
time, this was the only goal. But as I kept moving on, I started realizing there is a lot of friction when it comes to these, especially this particular LLM sort of niche.
Hmm.
Rust is not as evolved as Python is right now. And
Okay.
so after a while, it became an effort that we should just just work on improving the whole Rust ecosystem for AI or maybe just LLM. So that became the whole thing. And after
Hmm.
a while, we started seeing traction from folks in DSPy who wanted to try Rust.
Okay.
Yeah, it's actually so amazing that I expected that a lot of audience around this
Right.
would be DSPy folks who probably want to try Rust. And I have started talking to Chen and Omar both,
Hmm.
giving them updates and stuff.
Hmm.
And yeah, like after a while, people started coming in and most like it was like almost 50-50. People in Rust who want to try DSRs, and there are people who were
In Python, who
testing out
wanted to
like
try.
DSPy. Yeah.
Got it.
So
Got
it
it.
was a really good experience to work with. And so we just started building for both of the sort of audience. And there was one more guy who was building DSRS at the same time. It's yeah, like he was from AWS, so it was pretty nice. His ideas around abstractions for signatures
Hmm.
were really cool. Our
Okay.
signature inline signature abstractions are actually inspired by the design he did. And yeah, we had a chat with him over thread. It was pretty nice over there as well. So after a while, we just started observing, okay, what's the bottleneck in the Python framework that we could handle, or what's the bottleneck with Python that we could start solving with Rust? And it was my understanding at that time, maybe a lot of IO is being expensive in Python, which is because even simplest or cheapest stuff in Python are expensive usually. So my idea was, oh, maybe we should try optimizing for IO optimizations. And then we started dwelling into this domain of global optimization. My idea was that rather than just focusing on prompt optimizations, we could just expand everything and optimize the pipeline itself. If user provides your pipeline, you should be able to omit it out, edit it, modify it, and build an optimal pipeline out of it. So that's where DSRS really shined, because with DSPy, you need to change a lot of stuff to support this sort of infra. And I already have an infra which is almost in budding stages that I could change. So I just started DSRS as a research infra of sorts that supports this kind of optimization. So this was
Got it.
how DSRS sort of became a thing.
Came into picture. Okay.
Yeah.
So like, can we have some sort of like an apple to apple comparison between DSRS code and the DSPy code? This would help the viewers kind of get a sense of, how do I instantiate the LM? How does the signature look like? How can I create pipelines of, how can I create a module, right? Or so if you have something to show, that'd be great.
Yeah, sure. So I have something. Let me share my screen. Is it visible now?
Yeah, it is.
Okay. So this was a work from Haze Labs regarding using DSPy for red teaming efforts.
Mm-hmm.
So the idea is pretty simple. You have a LM configuration done over here. You use some clients and stuff. The idea is basically around these two modules. One that creates an attack prompt and one that
Hiram, could
tries
you
to,
you just
yeah.
zoom in? I think it would help. Yeah. Sorry.
Is it fine now?
Yeah, it's great. Thank you.
Yeah. So this is an attack module that creates an attack prompt, and then you optimize it, and then you sort of iterate again and again to create better and better jailbreak prompts for your LLM to
Right.
take on.
Got
So
it.
you create this signature, pretty standard DSPy signature, and this refined signature, and then you have this loop that goes on from attacking and refining and attacking and refining, and finally you just create the final attack prompt that you have.
Got it. And the critique is sort of funneled in back to the next call, right?
Yeah, to the
Okay.
next call in. Yeah.
Yeah.
Over here. So this is how this works in DSPy. In DSR, it's kind of the same. So we
Okay.
also support the
Could
same.
you zoom in the font?
Yeah,
Yeah. That'll.
sure.
Thank you.
This is fine. Yeah.
Yeah. This is great. Thank you.
Yeah. So in DSRs, we define a signature by this macro declaration, and then we say this is the structure. We say end attack, and this is the same instruction that we passed in DSPy's doc, and this automatically gets registered as an instruct. And this is how we define an input. So in DSPy, you have input fields and output fields.
Right.
In DSRs, we just define them by these attributes, and we'll say like description is this for this input field, for this
Right.
input field it's this, and so on.
Got it.
So this is how we can do this in DSRs. It's pretty similar to DSPy. And
Understood.
then we have these modules that we define via trait.
Mhm.
In Rust, trait basically define a shared behavior for a
Right.
particular structure and stuff. So what we do is we define modules, evaluators, optimizers, all of these as a trait to a model. So everything is binded to a single structure right now.
Got it.
So we say, this is pretty verbose because it's Rust, so we need to define
Right.
the fields already. So we
Right.
define some fields around it, and forward pass is almost the same. But one catch around this is that inputs are no longer arbitrary or different from signature or module to
Got it.
module. It's always going to be example, and result is going to be always prediction.
Oh, okay.
Yeah. So every time we pass something to a module, we convert it to an example before you curate it as an example. We
Mhm.
pass it to a module, and like DSPy has this thing called DSPy.context that uses different LLMs for different sort of tasks. We have forward with config where we pass the input along with the LM module that you want as the second argument, and so we just extract the predictions from it. We pass it. We use get response, which is a similar function we implemented as we did in the one before, which extracts the output from the attack prompt.
Understood.
And so we did it. Then we have a critique again and again, and this forms a loop. And then you have the last attack that's going on over here. And building LLM wise,
One, if you could just go back to the function signature for forward. So you chose to sort of deviate a little bit away from what is in the Python implementation, right? Do you want to talk about the thought process behind that?
yeah, for this, right? Like how we curate examples in this. Yeah, so in Rust, at least at the time when I was building it, I couldn't really figure out a good way of how we can initialize this arbitrary forward method as the part of the trait. So I just settled with this abstraction, and it works pretty fine because in DSPy we always have prediction as an output, which is in sync. But with examples, it can be different arbitrary sort of function arguments, which in Rust I didn't know how I should tackle at that point. So I just
Okay,
settled with
understood.
examples.
Got it. Got it.
Yeah.
Got it. But you'll be explicitly
Yeah. So yeah. Even DSPy explicitly calls it
calls it. Yeah, it's not part of Python object model. I mean, I think anybody who's done PyTorch a little bit would know where this is coming from.
Yeah.
Please continue.
Yeah. I guess what we wanted was a direct parity to DSPy's forward thing because it was so intuitive to us. So we really wanted to name it something like call or run or something like that. But for
Got
the
it.
sake of parity, we did it for the forward.
Understood. If I would ever to do a port, I would not use forward. I think that anybody who is from PyTorch or has done some work there, for them it's kind of very intuitive what's happening. And anybody who's not done that, they look at it for the first time and they're like, why is this the way it is, right? Like, but that's okay. This is a matter of taste.
Yeah. I think I have been using PyTorch extensively before I started doing DSPy. So I guess for me it was natural, and for the people who were into DSPy, for them it was sort of natural as well. So this just became
Correct.
a
Correct.
thing at
Yeah,
some
yeah.
point of time. Yeah.
No, I've met
But
both side of the audience while
uh-huh.
doing one workshop wherein there was absolutely nobody who had done PyTorch, and
Uh-huh.
in fact, half of the people had never done Python.
Wow.
So
Okay.
for them, it was not the most intuitive thing, but that's okay. Yeah,
Interesting.
let's proceed.
Yeah. And so building LLMs is kind of the same. For LLMs, we use something called as builder pattern, where we declare the initialization of some object as a function call itself. So if you want to initialize a model, we say, oh, I want to use Anthropic model, and we want
Hmm.
to use Claude's this particular model instance for this. For Gemini, we do this. For Grok,
Understood.
we do this, something like this. And then
Got it.
it's just initialization and just calling this module again and again.
Passing. Got it. Got
Yeah,
it.
so
I,
this
I
is
really
how the stuff works.
got it. In a lot of ways, it's a good apple to apple comparison, as in you pretty much implemented the same paradigm and pattern, just how it should be implemented in the language. So this sort of helps us and the viewers see how signatures, modules, and LM Builder works. Is just out of curiosity, what's on the roadmap for the library next? So I see you're working on GEPA for the project. Yeah, if you can throw some light, what's coming next?
Yeah, so we already have GEPA in DSRs right now. It works
Oh, okay.
almost similarly to the GEPA and DSPy platform as well. So there are quite a few directions that we can take for DSRS. One of them being we want to create 100% parity with DSPy right now. And that
Okay.
includes adding more modality for input, image inputs, video inputs, or audio inputs. And RIG which is our backend that we use for LM, sort of supports these
Mhm.
functions really nicely. So that's
Okay.
one thing. We want to create an internal abstraction for attachments like data format. So someone created, I think it's Maxim who created attachments
Right. Correct.
library for DSPy's input schemes, and we want to create a Rust interface for that as well. So that's another thing that we are thinking of right now. Aside from modality supports, we want to create a really good and more robust suite of adapters. So right now we only have chat adapter, which works the same way as DSPy does. We want to add like BAML, GBNF, NX grammars, and other sort of formats into this as well,
Okay.
just so we can test out these stuff more clearly.
Got it.
Aside from that, my idea is to improve Flop a bit more. Flop is the optimizer that I've been talking about, is global graph optimization, which traces the whole module, creates an execution graph out of it, and
Okay.
then it sort of edits the whole graph. So it's fine, it works good, but our idea is two ways. One is like we want to create it more of a whole pipeline optimizer. Like if you provided tools and stuff, it should be able to assign and change tools per module. And not just that, it should be able to optimize the tool itself. And by
Okay.
that, I really mean that the whole tool description that is out there should be optimizable to the for the optimizer itself as well. So this is
Okay.
one direction that we have been thinking to explore. Another thing is we want to make the whole graph tracing format a bit more robust, and not right now we support it in a way that works really well for Flop, but we want to make it in such a way that, oh, if someone comes in with an idea, oh, maybe this way the graph optimization could be better, we want to support that sort of infrastructure for research as well. So these are the few directions that we have been thinking to build DSRS in right now.
Got it. So by the way, I have no clue what flop is, to be honest, but
Oh, okay.
so kind of going to ask a fairly dumb question. Is it sort of like an execution graph that you construct before you actually start going from node to node and sort of executing? Is that the right way to think of it? So it's like a DAG.
That's exactly right. So with DSPy, what you have is you have prompt optimization. You go from module to module, you optimize the prompt, and you iterate it, you update it, and but the flow itself is the same. So we create Flop, which is flow optimizer, which traces this as an execution graph, and we take some inspiration from traditional compilers. So DSPy is like
Hmm.
50% compilation, and what
Hmm.
we want to do is 100% true compilation or 100% compilation, which is just trace the whole module as a graph and then just act upon it with these tools, what we call as split, fuse, and modify via some other optimize with some other module, and it just updates the whole flow of the program. And we have optimization tweaks, constraints, and stuff. But yeah, that's roughly the whole idea.
Got it. So I'm going to take a step back and just try to. So as of today, let's say that I have an agent running.
Hmm.
So at the start, I will expose a whole bunch of, let's say, a few MCP servers, right? And the LLM would basically pull and figure out which are the various tool calls it can make, what are the descriptions, and sort of registers that one shot, right? And then let's say I put up a prompt which has, if I were to decompose that prompt, it would, let's say, make up of four tasks, right? And so now it's on the LLM to figure out that, okay, I need to do task A. The output of task A will be called to B, then C, and let's say C and D can happen in parallel, and I can sort of fuse and merge the result and sort of display it. So are you saying that flop would be something that would basically construct this execution graph at the start and then sort of go ahead and execute it? Is that the right way of thinking about it?
That's right. That's the right way to think about this. More so, like it has the capability to know when to split one signature into two and fuse two signatures into one. So
Okay.
let's say there is one big signature and you want to just split it into two.
Hmm.
Now, the whole flop optimizer would critique on it and say, oh, it generates a whole plan first. And then using that plan as reference, it tries to say, oh, maybe splitting these two is better. Maybe fusing these two
Got it.
signatures into
Got
one
it.
is better. So
Got
stuff
it.
like that.
And so just curiosity's sake, if you want to execute any plan, which let's say would run for an hour, right? I mean, you rather show the plan to the user, so
Mhm.
sort of show the graph, execution graph to the user, and take his sign off that does this look good to you, or would this just be something that will always be autonomous, making decision on its own and not having like a human in loop? Like how would this, or it can work in both modes?
So right now there is no human in loop mode. It's fairly autonomous right now. There's yeah, there is no human in loop at this moment, but it's something that we have been thinking about a lot. Human in loop in general is something that we have to some extent. We have it, but it's only at the starting point. After that, it's just fully autonomous.
Ah, okay.
So yeah.
I'm pretty excited, and I'm gonna read more on this. And seems like where things are headed, any which ways.
Yeah.
Okay, so this brings me to our last question. So besides DSPy, what else are you doing? Where does your interest lie, and what is it that you're working on?
Yeah, so currently I'm sysmaxing myself, just diving deep into systems. I have been really getting a lot interested in domain specific compilation these days, which is also something I'll be pursuing in Stanford in my next quarter as well. So this is something I recently got interested in. Aside from this, I'm just gonna go really deep into kernel programming. I have this project called Spark Puppies, which is
Oh, wow.
yeah, it's basically Thunder Kittens like primitives, but for sparse operations.
No idea
The
what you're
reason
talking
I
about, to be honest.
oh, okay,
It's all
so
right. Just
Thunder
go
Kittens
ahead.
basically provides you interfaces that through which you can use style operations simply with in CUDA. And
Okay.
what I want to do, but it does, at least I don't think it supports sparse operations right now. So I was like, these guys missed their chance to use puppies in their framework name, so I should just use
Got it.
Spark Puppies and just do with it. So that's one project that's going on right now. I have developed a strange obsession with LLM routing these days. So I'm just trying to figure out how to build a really good continuously incrementing router for multiple LLM routing. What we want to do is so with LLM routing, what you have is you have a system of models that are out there. Now these could be
Correct.
frontier models, these could be
Okay.
local models and stuff.
Got it.
And you want to route your query to a specific LM that uses the
Okay.
minimal resources and
Right.
gives you the best output out of this. So
Ah,
not
okay.
every query has to be answered by the biggest model out there. Some could be
Okay.
answered correctly by 8B, some
So
could be
this is
answered.
not even at an application level. You're just talking about
Yeah,
like which model would be the right to sort of
that's
answer
right.
it. Makes sense. I
Yeah.
think Google is already doing that. If you ask it a bunch of questions, and in between that question would be a request to generate an image for something, and then another request with a URL saying that, hey, can you give me the audio for this particular, sorry, the transcript for this particular audio file. And I'm pretty sure they're calling Nano Banana, they're calling their speech to text transcription model, and then the normal LLM model. So I think this is already happening. And but there are a lot of uh, proxies, LLM proxies, what I think people are calling it off late.
Open router and stuff.
Yeah, so I think this is, but this will certainly, one thing that I'm a absolute believer of is that the same software, the same code base will be interacting with multiple models. One being a very large model and one being a very sort of SML kind of model, uh, and there is a high chance that, like, while developer can hard code that for this task always call the small model, for this task always call the large one, I do think that there is room for having a baked-in router library, which sort of decides which to call on its own, right?
Yeah, and there are quite a few libraries around this.
Oh, okay.
Yeah, and like I think AIBreaks was doing something around this. There is semantic router from VLM. I think VLM has their own thing for this as well. So there are a few libraries. What we want to tackle, I don't know if I can actually say that publicly right now, but there are some things when it comes to addition of more and more new LLMs that we want to tackle more optimally. That's probably how much I can say for this. So this is some the direction that I'm pursuing right now. So yeah, that's
Awesome.
roughly it.
That's great. So, Hiram, thanks for talking to us today. And we look forward to more contributions from you in DSPy.
Yeah, for sure. And thank you so much for having me over here.
All right. Thank you, Hiram. See you.
Yeah, thank you so much. See you.